Talking about malware analysis, and I'll demonstrate a little bit of automation with Binary Ninja. So I'm going to talk about what is Binary Ninja in case anybody hasn't heard of it. I'm sure most of you probably have. Also, why do we want to use it? I'm going to talk just really briefly about PlugX, which is a malware family. And then we're going to talk about the disassembly and the intermediate languages used by Binary Ninja. And then I'll show you some of the automation of PlugX. I'm going to go into a little bit more detail. I did this talk, a version of this talk at B-Sides Charm recently. So I'm going to skip over some of the details of the malware. So if you wanted to get more in depth into that, you can watch the videos online on an Iron Geek site. But I wanted to go into a little bit more detail with the API and some of the things the functionality that's good in Binary Ninja. So. About me, I am not at all affiliated with Vector35. They're the developers of Binary Ninja. I think all of them are here. Ryan, Rusty, and Peter are all here, I know. So you can always find those guys. I think they're all wearing Binary Ninja shirts. So if you wanted to talk to, I'm not an expert in this tool. I just wanted to try using it for my workflow. So if you have real detailed questions, it's probably better to find them. But I've been in the security industry for a while, doing malware reverse engineering, some digital forensics, some firmware stuff, some iOS programming. I was at DC3 a few years ago I was in the intrusions group doing defense network intrusions, mostly malware reverse engineering, but also some system forensic analysis. And right now, I just joined Carbon Black about a month and a half ago, so I'm with their threat analysis unit. I just wanted to make a few acknowledgments because the Binary Ninja community has been amazing. It was kind of, I'm sure any of you that do reverse engineering, you've been using IDA forever. And so going to a new tool can be really intimidating. You have to really learn kind of a new workflow around some things. And they made a lot of things easy. A lot of the key bindings are very similar to IDA. So that sort of transition made it a lot easier. But it's still, I'd never really had exposure to IL. So learning to program and automate things took a little bit to get my head around. It's kind of a different perspective. So some of these guys, the Trail of Bits guys, and gals, sorry, Sophia as well, they've been using Binary Ninja since basically the beta. So the very first thing that I actually read about Binary Ninja was a post by Ryan Stortz, who's also here. I think he's talking later today. And it kind of inspired me. He'd basically used it to solve a CTF where they did, I'm probably going to misdrew this, but basically they were able to automate the exploitation of 2,000 binaries with Binary Ninja. So some of these early adopters really helped to, all of their posts and things like that kind of made it a little bit easier to transition into using it. And Josh, who's also Trail of Bits, was an incredible help for me when I was trying to figure out the API stuff and lifting to the IL and all that. So he was a big help. And he has a really good series of blog posts. He just posted a third one recently that's kind of breaking down the LLIL, the low-level intermediate language. So I definitely recommend checking out their blog. Also, Jordan, who's Vector35, has been really supportive with any issues that have come up. And the community Slack, it's hashtag Binary Ninja. Everyone in there is super helpful, the Vector35 guys and just anybody that's using it. Everybody's there to answer questions. I've never had to wait for a question, for an answer to a question. Everybody's just really supportive and helpful. So just wanted to start out with that. So what is Binary Ninja? So it's a reverse engineering platform. Like I said, it's developed by the group Vector35. The first public release was back in July of 2016. I ended up getting my license around October of 2016. So it's been around, a couple years, but I haven't really been using it until recently for my actual workflow. But the robust API, the API is extremely well documented. You can actually program against the assembly, you can program against the lower level IL and the medium level IL, which we're going to talk about later. And you can actually use it in headless mode. The demo version doesn't have headless mode, but if you have either the personal or the, I believe personal, or commercial, you can actually just import Binary Ninja as a library into your Python script, which is really nice. You don't have to use the UI at all. So there's a linear disassembly mode, graph mode. The graph mode, you can either look in disassembly, the lower level IL, or the ML IL. We'll take a look at that later. There's also a fully featured hex editor that has built-in transformations, which is really nice. You can literally just, if you, let's say you had something that you need to XOR, you can just paste in either a single byte XOR, just highlight whatever you need to do, right-click and transform, just paste your key in there, single byte, multi-byte, whatever. There's RC4, base 64 decoding. You can actually just paste from. So if you copied some base 64 text, let's say, you can actually just say paste from base 64, and it'll just automatically decode it right there in the hex editor, which is pretty nice. The plugin architecture is open, and there's an open source community plugin repository on GitHub. It's on Vector35's GitHub page, community plugins. And like I said, the Slack channel is very active. Everybody there is super supportive, and learn a lot just lurking, actually. So why? So my motivation, I've been talking this up a lot, since 2016, and really trying to support these guys. But initially, the guys that developed it, it was mostly geared towards people that were doing CTFs or vulnerability research. Whereas, for malware analysis, it's a little bit of a different workflow. So initially, it was a little bit hard. There were a lot of things, like a lot of samples, not all of the functions would be identified. So once they actually put linear sweep into it, then I was like, okay, now I can probably start using this, looking at it more for malware analysis applications. And when I was talking to people about it, a lot of my malware analysis friends or colleagues, they always say the same thing. And it was the same thing that I said. It was, yeah, it's cool. I've loaded it up. I've thrown some binaries in there. But I just go back to IDA, because that's what I know. So at the beginning of the year, I was trying to figure out, what do I want to do for this quarter? I need to come up with a project. And so I said, why don't I just take something that's just a common malware analysis task and actually go through it end-to-end using Binary Ninja. So I figured if I can do that and then share my experience with it, what were the pitfalls that I fell into? How did I like it? Did it make things easier? Was it harder? And then I could just share that with some of my other colleagues. So that was the motivation. So what do I like about it? For one, it's a very easy entry into reverse engineering, because you can get a personal license for $120 or something like that. So I've actually heard that a lot of people in college classes and workshops and things like that have started using it, because you can literally give out licenses to each of your students pretty easily, because it's pretty cheap. Also, I talked about the API before. The documentation is fantastic. It's the Doxygen type of format, and I'll show it a little bit if you haven't seen it. But they also have they actually defined their own intermediate language as well. It's the Binary Ninja intermediate language, and it makes a lot of things a lot easier, like lifting to other architectures. They've tried to abstract that out so that you don't have to completely re-implement everything if you're trying to add support for a new architecture. So that's another good thing. But we'll see some examples of all these things as we go along here. So I wanted to talk about intermediate languages a bit. This was something that, I don't come from a computer science background. I did theoretical math, so it was something that I hadn't been exposed to before, this intermediate representation and intermediate languages. So like I said before, Binary Ninja implemented their own intermediate language, which a lot of people have asked me, why didn't they just do LLVM? But, and the full explanation, I'm sure the guys themselves can probably give a better definition of why, but the way that they've done the IL, it actually does go to, you can actually lift to LLVM or go back and forth with LLVM fairly easily. And like I said before, Josh's blog posts on breaking down the lower level IL, I definitely recommend reading about if you're more interested in it. But there was a quote here that I thought was really good from the documentation. This is actually from Binary Ninja's documentation directly. So it said that the BNIL is a semantic representation of the assembly language instructions for a native architecture. So it's actually a family of intermediate languages that work together to provide functionality at different abstraction layers. So I think that kind of sums it up pretty well. And they've got an HLIL format, which is going to be basically kind of more or less like a decompilation, and that's coming in a future release. I don't know that there's a actual release date for that yet, but this is kind of an off topic, but I saw this when I was at Charm. Ben Demick was doing a reverse engineering workshop using Binary Ninja, and he showed me this thing, and it's godbolt.org, and this compiler explorer, you can actually put in code, and there's support for multiple languages. This is C here. But you can actually, I don't know if you can tell the highlighting, but you can actually type your code in and see the disassembly. And it highlights what line of code roughly translates to the disassembly, which I thought was pretty cool. So kind of an aside, but. So intermediate languages, this is just kind of trying to get a overall kind of high-level picture of what's going on here. So basically on the left-hand side, we've got the straight disassembly. And actually, I forgot to plug in my thing. The straight disassembly there, I know you probably can't read that, but basically all I wanted to illustrate with this slide was that we're kind of, you can see that from the actual original disassembly, going up to the lower level IL, you can see that it's abstracted a little bit, like kind of one level. So our calls, instead of having our arguments pushed onto the stack and then call, you can see it's actually just call with arguments, actually in the, just directly. And then when you go up to the medium level IL, the variables, it's actually slightly more abstracted. So instead of having the release DC, moving the pointer, you just have the call to release DC with the arguments listed. So it makes it a little bit more human readable. Oh, there's that. I just found something I lost. Awesome. Yeah, so let me just plug this in so that I can point at things. All right, so, oops. All right, let's skip this. Okay. So here's just kind of a blown up view of this. Kind of just illustrating a little bit more what I was talking about before. So you've got the LLIL here. So here it's actually, the LLIL is making it an assignment, and instead of having this move instruction. And this .d, that's a binary ninja representation. This is just indicating that that's a D word. So you'll have .d or .b for a byte, that kind of thing. And so you can see down here, you've got the call, and again, it's switched this into an assignment. And then instead of having a jump, a test, and a jump, you're actually going to have kind of an if, then else statement, which makes it just, again, a little bit easier to read. So here again, here's the LLIL versus the MLIL. Kind of similar, but instead of having just call EDI, it's actually pulled in what that function is and giving you the parameters. And all of this is accessible from the API, which we'll see later. I can literally just say, give me this instruction, and it'll say, here's this, and give me the parameters, what are the values of those parameters, which makes it a lot easier to code against in some cases. So again, here's the MLIL versus the original disassembly. So again, we can actually get this instruction directly through the API. So binary view is one of the things that I didn't exactly understand when I first started, but basically when you load an executable or whatever into Binary Ninja, there are different views that you can actually access. And depending on which view you've told it to use, you have different functions and different APIs, different things that you can use to manipulate that view. So the very first thing you have to define, especially if you're doing this programmatically, you have to tell it, okay, I want to be in PE view for the case of like an x86 file. So I'll just actually switch over here real quick. Oops. I guess it doesn't. Okay, we'll do that later. All right, so anyway, this binary view module, you can have, for a portable executable file, you can have a raw view, which is, kind of think of it just kind of like you're manipulating the hex, or you can have the PE view, which would be your standard kind of IDA disassembly view. And within this module, you get a lot of these different, basically different things that helper classes that you can use, or convenience classes. So like one of them is binary reader. We're actually going to be I use both of these to do this PlugX decryption. You can actually read in bytes, and then you can patch them back. So with binary writer, you can actually patch back to the binary, which is helpful. That's not working. All right. So let's see if I can get this to come up. But I wanted to just kind of show a little bit, just a very brief look at the actual interface here. It's not wanting to switch views for me. Let's see if I can just... Sorry, I have problems with this machine with doing this a lot. Get out of this mode, maybe. All right, there we go. Okay. So here's the actual interface, and I forgot again to change my font. Let's make this a little bigger for you. So this is the actual binary Ninja interface. So this is the actual default view that you're going to see when you first load up a binary, portable executable here. This is a DLL. It's actually the PlugX DLL. So this is just the regular graph view of the assembly. And down here, I should probably actually, let me see if I can make this a little bit clearer so you can see it, because unfortunately the menu options are down here at the bottom. But right here, if you can see, we've got some menu options down here. So this one says PE. It's a little bit shaky there. We've got a PE menu, and then this graph, and then options. So down here is where you can actually switch between, let's see, PE or raw view. So here's the raw view. And depending on which view you're in, again, you have different options. So I can go back to the disassembly graph. There's a strings view, a linear disassembly, and then a types view. And so when you're in the graph view, you also get these options of the lower level IL or the medium level IL. You're not going to get that in linear disassembly because it's not, they don't have LLIL and MLIL in linear mode right now. So we can actually switch to the linear view versus the MLIL. So that was just one point of confusion when I first started, because depending on what view you're in or which options you have, it gives you different options on the options menu. So you just have to keep that in mind. So I just wanted to show real quick the types view. So this is where you can actually describe or define structures. And so we can right click here and just say, you can create a new type or a new structure or a new union. So if we create a new structure, we'll just give it some name. And you can optionally give it a size. If we don't give it a size, it's going to be just like IDA, where you can go to the end of the structure and hit Y and add a field. So you can just say like int foo. And you can add them one by one like that. But if let's say we knew the size of our structure, just say law2, we can actually say, I want this to be, let's say 16. And here, I can either just click at one of these locations and say, Y, like int foo, or you can actually highlight, if I just wanted a whole structure of D words or of integers, oops, you can actually just say, int, and it'll just define all of them for you there. And then if you messed up something, you can hit U for undo, which is awesome, or undefined. And if you're actually, that brings up a good point. So if I just took something and, let's go back over here. If I wanted to, let's say I'm just going to do something, this is stupid, but let's say I'm just going to call this, let's see, what were my, I don't remember what my things were defined here. Just go back to types view. So we've got a struct1. Let's go back to our regular graph here. So let's just say I wanted to define this as a struct1, and I messed that up. Then you can actually just hit U to undo that as well, which is kind of nice. But anyway, so let's see. So the LLIL and MLIL, I should show you the hex editor really quick. So we can go down here into the hex editor, and this is where I was saying, like, you can literally just either copy or highlight and then say, you can copy as a particular type or transform it and say, like, I want to encode this, base 64, or, you can encrypt, decrypt. You can do this. I can XOR, and I can just literally just paste my key in there. Makes it really convenient. And also, if you wanted to, let's just copy something here. So if I just copy this, I can say paste from, and let's say this was base 64 encoded. I can just say paste from base 64, and it would automatically decode it, which is pretty handy. So I used to use that a lot. So let's keep going here. I'll talk about the LLIL and MLIL a little bit later. So I'm just briefly going to talk about PlugX, just in case you're not familiar. And like I said, if you wanted to go a little bit more or get a little more detail about the malware itself, the talk from B-Sides Charm is posted, so it goes into a little bit more detail on this. But basically, PlugX is a rat that's been around forever. I figured it'd be a really good choice to demonstrate this because anybody that does malware analysis has probably seen it. And it's stayed pretty stable over the last 10 years. The first samples were seen back in 2008, and a lot of the samples still use the functionality of the very first variant, which is you've got a legitimate signed executable generally, a DLL, a malicious DLL that's side-loaded by that legitimate executable, and then you've got a payload, like encrypted payload and config. And that shellcode usually gets injected into some legitimate system process, so pretty typical pattern. I'm not going to talk about side loading, but that's basically how this PlugX, the methodology for how they get to run the code. And then it also uses process hollowing this particular sample, which again is just injecting into a legitimate system process. It's copying that shellcode in and executing it. So I will talk a little bit about the decryption method. After I talked about this recently, my friend Jimmy said, I don't want to use Yara. Could we use this IL representation to actually identify the decryption code rather than having to find a Yara hit and depend on that? So that's something that I want to look into. I haven't looked into it yet this talk, and I just realized I'm not in presenter mode here. But basically, the very simple method that I'm using is just, I've got a Yara signature that identifies this decryption code. I find the offset of that decryption code. I get the xrefs to that function, like where it's being called, get the parameters, because that's where my string is being passed in that's going to be decrypted, decrypt the strings, and patch back to the binary. So that's just basic methodology. So this obviously isn't the most optimized. This is not optimized Python code or anything. I tried to make it at least as clear as possible for readability. But basically here you can see this is the methodology I was talking about. I'm going to get the Yara offsets. These are the matches. So Yara, if you haven't used it before, you can also import that as a library into your Python script. So I just import Yara. I get the offsets, get the xrefs here. I need to get the XOR key. And then I want to decode and save it back to the binary. And ignore that print statement that was left in there. So here's the Yara code. Just skip through this a little bit. Basically just getting the offsets of the hits. It goes into an array. And then for each hit, I can get the offset for where that's matched and just return that list. So here's getting the xrefs. So here's where we get into some of the API. Again, like I said, the very first thing when you start, actually let me just pause there for a second because I forgot to mention. So when we do that binary, get that binary view, we've got this, this is still kind of small, but hopefully you can see it. So we get this binary view, and you can actually add the analysis option here. So it doesn't run linear sweep by default, but you can add this analysis option. There are more, but you can add linear sweep here and then just say update the analysis and then wait for that to come back before moving on. Switch me back into that mode. All right. So just a quick aside. So basically this binary view module, the API gives you functions for getting the address for these data offsets. And in the API, all of the calls, even though at first when I started doing this, I was like, God, these are really annoyingly long. Like I'm tired of typing all this stuff out. But it is nice that they're actually really descriptive. So it's like, I don't remember what that function was to get the offset, but I can either search in the API documentation pretty quickly and find it, or it's pretty self-descriptive. So you can get the address for the data offset and just give it an offset, and we can get the functions containing that offset. And then for each of those functions in the list, I want to actually get the code refs. So this is just getting the xrefs to that function. And here again, looking down here at we're getting into the IL now. So this was one thing, excuse me, that was a little bit of a stumbling block for me when I first started. Because in IDA, I was used to, okay, I've got my Yara hit, I'm at this offset, I'm gonna step around until I find the call, I'm gonna step back, see what was pushed onto the stack, and then move all that stuff, and then I'm moving around in the assembly. Whereas in this one, if you go up to the IL, you can actually just say, give me the low-level IL at this address. And then you've got these basic blocks. So you can actually just iterate over the basic blocks. So if you're not familiar with basic blocks, actually I'll talk about that in just a second. But down here, so we go through these basic blocks and we can get the instruction indices and look at each operation. So I can say for this intermediate, this instruction, what is the operation? If the operation is a set reg and the source is an XOR, so source.operation, you can have for each of these instructions, you've got the operation itself, and then source would be you've got the operation, the XOR, this operation here, and then you've got the right argument and the left operand, sorry. So you can actually just pull those directly from the IL without having to say, well, was this pushed on? What was the call? What type of call was it? Blah, blah, blah. So it makes it kind of nice. So here, I just wanted to talk about the basic blocks. Because at first I was like, well, why do I need to do this? But basically you can kind of isolate. I can say, here's my Yara hit down here. Give me the basic block that this is a part of, and then I can get the start of the basic block. So instead of having to jump around or start from the beginning of a function and go down, you can say, I just want to look at this little chunk here and identify my target code there. So that's what we're doing right here, iterating over these basic blocks. All right, so this is the actual decryption code. Very simple, but so again, we've got this binary view, and in order to read in and patch back this binary, I want to define a binary reader and a binary writer. And I'm going to look at all these xref functions, basically. And here I say, okay, for each of these xrefs, give me the low-level IL at the xf address, and then I want to get the medium-level IL at that same address. And I think this is going to change a little bit from what I remember talking to Josh about. I think that it's going to be, I'll have to confirm that, but where you'll be able to go directly to the medium level, but don't take my word on that. For right now, it's a property of the low-level IL. So we can check the operation and say, so is this operation a call instruction? Then I can get the parameters, and I want to get the string, the size, and this kind of arithmetic, this offset thing that it uses in the decryption. Oh. Oops. Yeah, okay. So here, when we're looking at this low-level IL at the address, we can see that this is an MLIL call. So that's what this, we can tell that it's a call. And this medium-level IL object, and I can show this to you in the console, basically it's going to give you this highlighted thing right here. So this is the call, these are the parameters, and you can just access each of these this way. Let's show it here in the next one. So you've got this params. So your params is this list here. And the value, you're going to have each of these values. So param 0, value 1, and 2. So we can very easily get our operands, our information that we need to decrypt these strings. And down here, I'm reading in. You can read. There's different operations, read operations, but I'm reading in 8 bytes at a time, and basically performing this simple encryption. It basically just subtracts this parameter here, this 0x95, XORs with key, and then adds that value back. Very simple. So I need to go back to, so let's just look at some of this in the actual console. So if we look back at the actual binary, so here I've loaded in our our malicious binary, malicious DLL, and we're here at the beginning of the file. And so you'll notice over here on the left, these are our functions here. We're actually missing a function here, so I haven't actually run linear sweep yet. So we'll see once we. And we've got down here our xrefs. So we're actually missing a bunch of xrefs down here. So when I noticed that, it's like, oh, I need to run linear sweep module. So right now it's not actually run. It doesn't run by default. But we can see once we run that, we get the rest of our xrefs and this additional function that wasn't being identified before. So we can actually, if you just hover over one of these xrefs, you can actually get a quick view of the code, and we can jump there. So here we can see the call to our decryption function with the parameters. And so right here, again, if we hover over this is where our encoded or encrypted string is. So we've got this memory location, and this is where, when we finish decrypting the strings, we're going to patch it back to this, so that after we run our script and load this back into either Binary Ninja, or we load it into IDA or whatever, those strings are all going to be decrypted here. So you won't have to make comments or any of that kind of stuff. It's already just patched right back in there. So if we double click on that memory location, we can see here, this is where the location of those encrypted strings that we're going to work on. So after we run the script, we can see this is the patched binary. So we'll just look at one of these xrefs again, and you can see now the call to this. Let's put this back into MLIL. The call here, we've got our memory location, the same memory location, but now at that address is virtual alloc. So you get that, it's just in there. So even if you loaded this up in IDA, it would have the patched version. So you can see here, now our memory location actually has these decrypted strings in there, which makes it a little bit easier to analyze. I don't know why this keeps switching back to that mode, but so I wanted to show, I guess, because you can, if you don't necessarily have to do all this in headless mode. if you're just trying to figure some things out and play around with the API, you can do this all from the script console down here. So basically the first thing that I did, and I don't know if I can make this part bigger, the text, but basically what I'm doing here, you've got a binary view, so you want to set your binary view, get view of the file, and then you can do operations on this binary view after that. So I can get the address for a data offset, the functions containing that, and print those out. And down here, I wanted to show, you can actually, so the IL params that I was talking about, you can actually just say, give me the value for, so here's the IL like I was talking about. So this is what, when you get that instruction, that IL instruction, this is the actual medium level IL instruction there that you can access. So you can access all parts of this. You've got the actual parameters here and the values within it. And so you can see here, I just printed out the first value here, which makes it a lot easier in terms of, I think, especially if you're kind of new to assembly, you don't really have to, you can think of it a little bit more semantically, which is nice. It makes it a little bit easier to manipulate these objects. So I'm going to pause for a minute. I think we've still got 20 minutes, but just if there's any questions, when I was doing this, I was like, well, I want to talk about this, the same thing, but I want to go into a little bit more depth because of, you guys are mostly, a lot of people are reverse engineers, probably a lot of malware analysts here. A lot of people that maybe have tried Binary Ninja, maybe opened it and kind of poked around at it. So in conversations with people over the last few days, I've been like, what kinds of things do you have questions about or that you would want to see? Like, how do I do this versus IDA? And so like one of the things that people had said was the structures view. So you can do a lot from that types view. But I don't know if there are other things that people are interested in, things that you would want to see more detail in. Certainly if you have any questions, I'll go ahead and just pause here and see if anybody has questions about what I've already shown so far. Anything that I need to go into more depth on? Anybody? Bueller? No. So yeah, there were a couple of. Yeah, it's definitely worth though. Actually, let me talk about some of these resources. That's probably a good way to go. So one thing I would say is there was really good, one thing that I just saw recently, like I was talking about the Trail of Bits, the people at Trail of Bits. Last year at Infiltrate, Sophia, who's with Trail of Bits, and then Peter and Rusty, who are here with Victor 35. They actually did a really good presentation on, it's called Be a Binary Ninja Rockstar. You can find it online. That was at Infiltrate, like I said, last year. And if you wanted more detail on how the IL works and why it makes it a lot easier to lift to other architectures, I definitely recommend watching that. They obviously know a lot more about intermediate representation and the implementation, obviously, than I can provide. But I definitely recommend that talk. And like I said, the GitHub here for Vector 35, there are a lot of community plugins on the site, as well as all the documentation, which you can find at api.binary.ninja. Slack channel, also I highly recommend, even if you just want to lurk and kind of just hanging out with the people in there and seeing the questions that get asked and the solutions. It definitely helped me learn more about the tool. And like I said, everybody there is extremely helpful. So I'll just show you here. So I have a little bit of time. So here's the community plugins page. And so anybody can contribute these plugins. They give you There's kind of examples down here in their GitHub repository where you can kind of follow along to the format. But there's basically just a plugin.json, and you can generate a README, and then there are some required fields. But basically, if you look in here, oh, I don't think I have. Let's see if we can. Oops. But there's quite a few community plugins already. All right, well, I'm not going to be able to do that. There's quite a few community plugins existing right now. And on the Vector 35 GitHub itself also, there's kind of this getting started guide. And one of the things I definitely recommend is looking at the hotkeys. Like I said, most of them are very similar to IDA. So, spacebar will toggle between your disassembly graph and linear. G is, go to if you want to go to a particular address. P to create a function. When I was changing the type, again, Y, just like IDA. So, comments and things. But this little get started guide is pretty helpful. Again, I would definitely recommend also looking at both the Trail of Bits and the Vector 35 blogs. They do tend to have quite a few posts using Binary Ninja, and I've gone through Josh's, and he does a very good job of kind of stepping through things. So if you wanted kind of a walkthrough, I definitely, some of his posts, and then also on the Binary Ninja guide itself to LLIL. This kind of explains it, and so you can see the initial, so when you're coming from the assembly, the very first stage that comes from the architecture plugin, depending on what architecture you're looking at, is this lifted IL. So once you lift from that, you get to the low-level IL, where the flags are resolved. The SSA, that was one thing I wanted to talk about. So there's also an SSA mode, which if you're not familiar with it, this is something I didn't know about before, but it's a single static assignment. And basically this means, this is helpful for when you're looking at data flow, because basically if you have a variable, each variable in a function can only be used once. So if you have a variable that's actually reused, then it gets a different name. And this goes into a lot more depth with phi functions, which Sophia actually talked about in this talk from Infiltrate, the Be a Binary Rockstar. She goes into more depth on that, as well as Rusty talking about the LLI and MLIL. So if you're curious about that, this is in the docs for Binary Ninja. So at the medium level IL level, you also get the stack resolution. Excuse me. And then on the roadmap here is also the high level, which is going to be more like a decompilation, as I mentioned. But the nice thing about this is that there is a binary here that you can download and actually walk through this whole example directly to get a better understanding of the low-level IL. And just while I'm here, I'll show you. So this is the actual API documentation, kind of standard Doxygen type format, and very easy to search. But you can actually get all of the enums here. So let me make this bigger. So like when we were looking before, when I was testing the operations, these low-level operations, you can test, there's the add or call or whatever. And this is all documented. Also, I'm not going to be able to click on it. Let me see, did I do? No. So for each of these modules, a lot of them actually have examples listed as well, which is nice. So this is an example of binary reader and how to use it. And you can actually have an optional parameter for endianness if you wanted to switch that. So there are different parameters so you can pass in. Like this binary view type, you don't necessarily have to specify, but if you wanted to, you could actually say, open it with this view. So this goes into all the methods, and you can actually get to the source as well. So if you needed more information about a particular method or something, you can actually link to the source for those, which is handy. So I think that's mostly what I wanted to talk about here. But again, if anybody has any questions, please let me know. Yep.
So you showed some programming in Binja. Did you do a lot of the work with API in IDA? And then follow-up question for that, are there any plugins in IDA that aren't available in Binja that you wish there were? And then final question, disassemblers win.
Sorry, what was the third one?
Disassemblers win, it's a joke.
Oh, disassemblers win, gotcha. No, so that is one good point. So when I was talking to some people about this when I gave it the last time, I didn't realize that the IDEA has actually exposed the IL now in 7.1, I think. I think Ilfak was giving a talk on it at Black Hat. I think he gave one recently as well. I haven't had a chance to look at that, but I'd be interested to see how they are implementing the IL, because that definitely will expose a different level of interaction from IDA Python. But for me personally, I found, because I actually have implemented this before in the past in IDA, this particular PlugX decryption, I will say that once I kind of got my head around the using and working with the IL, it was 1,000 times easier than when I've implemented it in IDA Python. And granted, I'm not the experienced IDA Python person that probably a lot of people are, so that's part of it. But I did find that starting from scratch, so basically this is a little bit of background that I didn't go into. So I was at DC3 in the government, working a SCIF. So when I left that job, I had to leave all of my scripts behind, all of my frameworks, all of everything, and start from scratch, basically. So I figured, if I'm gonna have to start from scratch anyway, it's a good time to try out a new tool. Because when you already have all of your scripts written and things, it's hard to be motivated to move to something new. But I'm glad that it did it, because I do think that it is a lot more friendly, I think, to in terms of barrier to entry, in my opinion. But everybody has their favorite tools. So a lot of people are still just more comfortable with IDA. But it is, I will say that the growth that they've had, especially for having 3 developers over the last 2 years, has been amazing. And a lot of times in Slack, actually my friend just the other day is like, well, I was looking at implementing this architecture, how easy would that be? And they're like, I really need this feature. And so Ryan was like, oh, well, give me an hour or 2 and I'll get that into the build. And so it's like, sometimes those one-off things, if you let them know kind of features that are important, sometimes easy fixes, they just end up doing them right away, which is, the responsiveness has just been, it's very impressive, especially for the resources that they have. But did that answer your questions? I feel like I missed one.
Yeah, that answered the first one. What about plugins? So do you use a lot of plugins with IDA that aren't available in Binja, or do you have that problem at all?
Yeah, I guess the only one really that significant one that I can really think of off the top of my head would be bindiff. But
yeah, that's requested a lot.
Yeah, that's a big one, but especially with malware. But that's also not even available in IDA 7. So, that's the only one I can really think of. But obviously, there's a ton of plugins. I'm probably just not thinking of it right now. But yeah, the plugin architecture is very easy. The samples are very easy to follow. The script that I used to kind of base this off of was something that gave binary info. And so kind of following that example, it was very easy to just kind of modify and turn it into what I needed. So, and like I said, the community is super helpful. So it makes it easier.
Any other question? Okay, then thank the speaker again.